What's up, folks? Good evening. This is Mr. Moray coming to you live with a little video on systems of inequalities. All right, and so my goal is to help you really brush up on some of those skills, maybe answer some of the questions that you might still have, and give you an opportunity to kind of see this from a visual perspective. All right, real quick, and I know I promised some of my students I would do this to help you stay up to date with all the videos I got. Make sure you go ahead and click that subscribe button. And if you like this, please don't hesitate to leave a like or a comment so I can help make these videos relevant to you. All right, so I've got a few systems here I'm going to graph. Note that I'm going to do one of them in red, one of them in blue, and then you're going to see the overlapping shaded region because that's where the red and the blue will overlap, okay? So remember, these are systems. They're systems, meaning there's more than one of them on the graph at the same time. They're systems of inequalities because the things that we're graphing are inequalities, and they're two variable inequalities because each inequality has two variables, in this case an x and a y. All right, I'm going to start out by showing you that these are in standard form, okay? And as I said in class, there's a lot of skills that are going to be building here. The first skill we need to know is how to graph a line in standard form, okay? So if you don't know how to graph the line in standard form, that's going to be a problem because you have to first graph the boundary line, second, figure out if the line is solid or dotted, third, plug in the test point, and fourth, based on the test point, shade above or below. So I'm going to show you how to do the first one. I'll start with the red. We have 2x plus y is greater than or equal to 4. So my first step is going to be to graph the boundary line. Okay, so to do that, I'm going to find my x and my y intercepts. To find my y-intercept, I'm going to cover up x because that means x is more than 0. And remember, the equation for the boundary line is 2x plus y is equal to 4 because a line represents an equation, okay? So now I'm going to start with my x and my y-intercept. So when I cover up x, that means x is 0, okay? And when x is 0, see, what does y have to be? It has to be 4. So 0 plus 4 is equal to 4. So 1, 2, 3, 4. I plot my y-intercepts. Now I'm going to do the same thing. I'm going to cover up the y, and I know it's kind of hard to see. What you get is 2x equals 4. Okay, and maybe I should label this. So this is 0, 4. Now I'm going to put my y-intercept when y is 0, or rather, sorry, my x-intercept. So I have 0, and when this is 0, 2 makes that true. So I have 2, 0. So my x-intercept and my y-intercept. And now that I've got both of those points, what I'm going to do is I'm going to go ahead and connect them to make a line. And to help me, I'm going to use my friend here, a little keyboard. And if I get this keyboard with a little pen on it, that's all right. Now, you might have seen this is an or equal to inequality. So I'm going to go ahead and connect it with, remember, a solid line. Or equal to means solid line. And I might not get it perfect at first, and you know what? That's okay. Okay. One thing we want to remember when we're graphing these is make sure it extends to both ends of the plane. You got to get it going as far as you can. There's my line. Okay. Now, my next step is going to be to choose a test point. And remember, we're not going to be a hero. We're going to choose 0, 0. Okay, so now we're going to plug in and ask ourselves, does 0 make it true or false? The original inequality. So if I plug in 0, get 0 plus 0. So I've got to ask myself, is 0 greater than or equal to 4? No, it's not. 0 is less than 4. So that means I'm going to shade on the opposite side. Now, I got some questions in class. Why, Mr. Moray? Here's the deal. Remember that the boundary line always separates the points that are true and the points that are false. Meaning, the false stuff is on one side and the true stuff is on the other. By plugging in the test point, it's great because if the test point makes the inequality true, then everything on the same side is true. But if it makes the inequality false, then everything on this side is false, meaning everything on the other side is true. Okay? So now I'm going to go ahead and do the second one. And remember, I'll do this in blue. So now I've got 3x minus 2y equals 6. So I start with my boundary line. 3x, and I'm sorry, this is less than 6. So I'll start with my boundary line. 3x minus 2y is equal to 6. And now I'll go ahead and do the same thing. So I'll cover up my x. So I've got negative 2y equals 6. So y is equal to 1, 2, negative 3. Because negative 3 times negative 2 is positive 6. Now I cover up my y, and I get 3x equals 6. So x has to be equal to 2, because 3 times 2 is 6. Okay, and that's the idea. So I've got 0, negative 3, and 2, 0. And now what I'm going to do is, again, take my little makeshift ruler here. Wow, I did a lot better this time. And you know what? If I get a little pen on my keyboard, it's whatever. It's okay. I can live. Okay, here we go. Now, what kind of line is it supposed to be? It's supposed to be a dotted line. So I used pen, so I can't really erase. So what I'm going to go do is I'm going to come in here and see what I'll do. I'll just color every little bit. Make it a dotted line. Why is it a dotted line? Because it's not equal to, it's just less than. And remember, the line is where they're equal. So when you have not equal in your inequality, meaning just less than or greater than, the stuff that's equal doesn't count. Okay, lastly, I'm going to choose my 0, 0, noticing 0, 0 is not on the line. And I'm going to ask myself, right, if this is 0, 0, if this is 0, 0, so is 0 less than 6? Yes, it is. So what that means is I'm going to shade on the same side of the line as 0, 0. And notice right here in this top part, this right here is the solution region. So what we would do is we would shade this region a little extra dark, or we could point to it, solution, okay? But notice how this is actually really beautiful. We've taken the plane and we've cut it up into 4 quadrants or 4 slices. One slice where the whole system is true, right? Both of them are true at the same time. We have these slices where only one of the inequalities are true. So here, only the blue is true. And here, only the red is true. And then finally, we have our fourth one where neither of them are true. And in many cases, except perhaps when the lines are parallel to each other, that is the situation we're going to be in. Okay, so if you need to rewind and see how did I do that, go ahead and try to do that. And then in a second, I'm going to move on to the next one. Okay, this one I'm going to go ahead and I'm going to go a little bit faster now that we've had a chance to build up those fundamentals, okay? And what's really nice about this video is that if you're stuck, that's okay. You slow down and you can go back through it. That's all right. So now I'm going to start by graphing, and again, notice that these are in standard form. These are going to both be dotted lines because notice that there's no or equal to. So again, I'm going to start with the intercepts. So I cover the y. So remember, this is the boundary line. Okay, I cover the y. How about we start with the x? I cover the x. I've got negative 4y equals 12. So y equals negative 3. So I've got 0, negative 3. Then I cover the y. I've got 3x equals 12. That represents 4, 0. So I do 0, negative 3. I do 4, 0. And now I connect with a what kind of line? A dotted line. And notice how I'm putting the arrows on the ends. I've got a great friend, HB. She would appreciate all those arrows that I put on the lines. HB is the best, okay? So she would really appreciate me right now for always remembering my arrows she's going to turn out real well in life because she's always going to remember her arrows all the time. What would do that, HB? All right, now I'm going to plug in 0, 0. And I'm going to ask myself, is 0, remember, 0 makes it all go away. A student in class, you might remember, asked me, hey, Mr. Moray, could I choose 1, 0? Sure, you could, but think about it. It doesn't matter whether you pick this point or this point because neither of them are on the line. So you might as well choose the easiest one possible, okay? 0 makes everything go away. And so all I'm left with is 0. And is 0 less than 12? Yeah, it is. All right, so because 0 is less than 12, I'm shading on the same side of the line. Okay, now I'm going to do the second one. Here we go. So now I've got a graph x plus 2y. Let's start with the boundary line equal to 6. So again, I cover my x. 2y equals 6. So y has to be 3. Now I cover my y. All right, difficult to see, but I get x equals 6. Think about if you covered that y with your finger. If I made it go away with my, there we go. See how my pen's blocking it? So what's left is x equals 6. So again, I graph my points 1, 2, 3, 4, 5, 6, and 0, 1, 2, 3. And remember, I'm going to now connect it with a dotted line. All right, and I love this keyboard. It's really good in terms of becoming a ruler right now. It's not so good because I'm not actually using my computer, but it is amazing in terms of drawing a line. Now, your lines don't have to be perfect. Guys, I'm not judging you for having perfect lines, but they got to be reasonable, all right? And if you're like, man, these lines are really tough to do, just remember, it comes with practice, all right? It takes a little bit of practice to really master that. All right, now I'm going to do 0, 0 again. Does 0, 0, well, 0 is less than 6. Is that true? Of course. So now I'm going to shade below this line. And notice, here's my solution. So again, I've got region 1. This is the solution. I've got region 2. Only the solution to the red. Red only. Okay, I've got quadrant or piece 3, only solution to the blue. And then I've got part 4, neither. Okay, so your goal when you graph a system of inequalities is only to identify the solution region. And in terms of doing it, you got a couple options. On a quiz or a test, I'm actually okay if you want to borrow a colored pencil and show me the overlapping colors. 100% okay by me. Option 2, you can darken this region, make it nice and dark. All right. Make it way darker than the rest or point to it, but you got to indicate where that overlapping region is because that's really important. That's where the solutions are at. Okay, now I'm going to go ahead and go down to our next one. Pretty similar. So now in this one, I'm going to go a little bit faster. And if that means you want to go back and take a look at the other ones, that's totally cool. So again, I'll start with the red and let's start with our intercepts. So if x is 0, y is -3, 1, 2, -3. If y is 0, x is 6, 1, 2, 3, 4, 5, 6. I connect it with a solid line because it's or equal to. All right, and you know what? This is something that takes time, right? Practice makes perfect. I remember, I never expect people to be like, boom, I got it in one day. If you can do it the first time around, that's good. That means you got to be a leader and help the people who don't get it the first time around. And if you don't get it the first time around, that's all right. I never judge you. The only thing I want to see is that you don't give up. You keep trying, okay? You keep coming back and you keep trying your best to make it better. And if you're watching this video, that's a sign that you're doing that. Now, I go with 0 less than or equal to 6. Of course, right? So I'm going to shade above because I shade on the same side. All right, second one. 2x plus 3y is equal to 6. What does that mean? That means cover up the y. So y is 0, x is 3, 1, 2, 3. Now I cover up the x. I solve for y. Y is 2. Okay. Connect it. Now notice the big step here is that I'm no longer giving you that additional boundary line equation, right? All right. Hopefully this keyboard works out well. And you guys can't see this, but I'm standing from behind it. Oh, wow, I got lucky there. I'm standing from behind it, so I'm really got a lot of faith in it. I couldn't see where that was before I drew it that time. All right, again, 2 solid lines, 2 are equals. I do my 0, 0. Is 0 less than 6? We already know it is. Shade it again, and we see the overlapping shaded region right here. Make that nice and dark, and there we go. So again, we got region 1, solution to both, region 2, red only, region 3, blue only, region 4, neither true. Okay, so again, if you need a minute, go ahead, rewind that back, and then I'm going to move on, and I'm going to go even faster on this last one, and then I'll show you a special case. All right, here we go. All right, so here we go. On this last one, first, boundary line. X is 6. 1, 2, 3, 4, 5, 6. Y is 0. Y is -2. And X is 0. I take the points. I connect them with a dotted boundary line because it is is not or equal. Okay? And remember the HB rule. Arrows on the end. CHB, don't kill me, HB. I got it. All right. Choose my test point. 0, 0. 0 is not more than 6. So on this guy, I'm shading below. All right. Now I hit the next one. Right, just like you hit that. Whoa. Whoa. I'm going to hit the next one. And it looks like on the next one, what the heck happened? Did I lose my... Oh, nope, there's my pen. All right, now, here we go. 0, 1, 2, 3, 4, 5. Now, this one's going to be tough because it's 2x. But what I want to do, I got a couple options. One option might be to find another combination. For example, 2 and 1. That would work. Okay, alternatively, I could go 2.5 because 2.5 times 2 is 5. Okay, no worries. Remember, you can really find any combination of points that make both sides equal to each other. All right. Dot it. Uh-oh. Points on the ends. I choose my 0, 0. Is 0 more than 5? No. So I'm shading on this side. And I got my overlapping shaded region right here. Okay. So this is 4 really quick examples of how do we do it in standard form. For my last example, I'm going to show you a special case because remember, when the lines are parallel, which means either they have the same slope or, in other words, they never touch, right? That's a sign you're going to either have shading in between them, meaning you got solutions, or shading outside them, meaning no solutions. Let's take a look and see what case this is. Now remember, these are in slope-intercept form. So I start with my intercept, which is 2, and I'm going to go for the red, up 1 over 2, down 1 left 2, down 1 left 2, up 1 right 2, connect them with a solid line, and I'm really feeling confident, so I'm not going to actually use my ruler. Again, I choose my 0, 0. Is 0 more than 2, right? If you plug in 0, you get 0. This becomes 0. True? Nope. So I'm going opposite side on this one. Now I go down to my second one. So I do 1, 2, 3. And I'm going up 1, right 2, up 1, right 2, up 1, right 2, down 1, left 2, down 1, left 2. Connecting it with a dotted line. Boo, 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 do, 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 do. Arrows in the end so no one gets mad at me. Now I try it again. Is 0, maybe I'll do this in blue, is 0 less than -3? No, it's greater than -3. So now I shade on the other side. Now, where's the overlapping shaded region? There is none. So this one has no solution, okay? The individual pieces do have a solution, but the overlapping shaded region is where the solution to the system is, okay? And in this case, there is no solution because the shading does not overlap. Remember, you only get this, only possible if the boundary lines are parallel, okay? Only when the boundary lines are parallel can you have no solution. Why? Because there's only two types of pairs of lines. Lines that meet and lines that don't. If the lines meet, there's going to have to be a crossover of shading, okay? Because at some point they're going to meet, and you either got a shade on one side of the line or you don't. So where they meet is essentially, as you might notice in this example, maybe this example, where they meet is generally going to have to do with where the overlapping region is. However, parallel lines never touch, never meet. So therefore, that's going to be a case where either they'll shade outside or inside. And remember, parallel lines always have the same slope. Okay, that's how you know you got a parallel line. All right, so I know this has been quite a video. I know it's been a decent length video. I hope that you found it to be interesting. I hope you found it to help maybe clear up some of those questions you have. You know, again, if you found this video to be interesting, if you found that there's some value out of this, please go ahead and subscribe, maybe hit the like button, maybe leave a comment so I can continue to make this better. But remember, no matter what, keep believing in yourself because you can do it, okay? So stay positive, keep your head in the game, don't forget to love math, and have a wonderful day.